All right, so today we're going to try to finish up the transformations notes, but if we don't get to, we'll have a part 3 tomorrow. All right, so yesterday we talked about a translation, which was just a slide. So today we're going to get into 2 more transformations, okay? And we're going to take a look at what is changing between these 2 linear functions. Yesterday, the slope was staying the same, but the y-intercept was changing. So let's see what happens today. It says graph the following functions on the same coordinate plane. So kind of the same setup to explore what's going on. So I can see on this first one that the slope is 1 over 1 and the y-intercept is 2. So I'm going to start here at 2, go up 1, right 1, where I can reverse the slope and go down 1 and left 1. Go ahead and graph that line. I don't like the way that's looking. All right. So that's y equals x plus 2. Take a look at this one. Here the slope is 1/2 and the y-intercept is 2. So same y-intercept. And I don't want to put that around there just yet. The slope is up 1, right 2. Or we can go down 1 and left 2. And let's graph this one. So we're going to name the difference between these 2 equations. First of all, I'm just going to put what's the same. The slopes are different, but the y-intercepts are the same. And we can say same y-intercept, but also remember it's calling an initial value. What you originally start off with, especially if this were a word problem, and what you originally started off with would be your y-intercept or your initial value. And then let's talk about what's different. The slopes are different. And this would have been nice to show on the smart board, because with Smart Notebook, you can rotate figures or lines. So it would have been nice to show. And this is an actual rotation, guys, but it's hard to show this on here. So it's going to tell you, it's going to ask you to describe the transformation that occurred. This is a rotation of a line. So your original line was in red. This line right here. This line has rotated to this position. And when the top part rotates there, the bottom part rotates up. So basically the whole line moves and turns into this green line, the red line. So if you can pull the top of the line down or turn it down, it can turn into the green line. At the same time, when you pull the top of the line down, the bottom of the red line goes up. And that's the new position is the green line. So as you can tell, the steepness of the line, if you take this red line, which has a slope of 1, and it changes it to the position of the green line, the red line is steeper than the green line. It's steeper to begin with because the slope is higher. Here the slope is 1. Here the slope is only 1/2. So it's going to be steeper. The greater the absolute value of the slope, the steeper the line. So it's steeper. And then when you turn this thing, when you turn it to only having a slope of 1/2, the line is less steep. So this is steeper because it has a slope of 1. And this is less steep because it has a slope of 1/2. So again, turning it can either make your slope steeper or less steep, guys. Because I went from a slope of 1 to a slope of 1/2, my slope was less steep. But it was still a turn, or what we call a rotation. Basically, it was turned or pushed down, turned down. Now, how did this thing turn? It turned, there was a fixed point. It turned about a fixed point. Well, now, what was that fixed point? So you see the point that they shared? They both had 2 as a y-intercept. That's the fixed point. So this red line turned on this y-intercept 0, 2. It's almost like if you take one of those pens that I put papers up with on the bulletin board in that Smarty Pants bulletin board, those thumbnail pens or thumbtacks, and pretend like that's the thumbtack right there, and you rotate that red line down or push it down, it's still going to rotate this point where this thumbnail is, or thumbtack. Maybe this point right here, if I put the thumbtack there, it wouldn't move, but the rest of the red line will move. So it's turning about this point, which is the point 0, 2, or your y-intercept. So that fixed point, that point that's not moving, is 0, 2, which is your y-intercept, because it was the same in both equations. So I'm going to say this is a rotation about the y-intercept, 0, 2. Like I said, I wish I could have shown you this on the smart board and actually turned it. You could have seen that it was going around 0, 2, that fixed point. But I hope you understand that the red line is being turned down, so the slope is being decreased or less steep than the original slope. All right, and I'm going to go ahead and put that y equals to x plus 2 is less steep than y equals to 1/2 x plus 2. I want you to know what changing the slope does, like if you increase the slope or decrease the slope. And again, I'm looking at to determine steepness, I'm looking at the absolute value of the slope. And just remember, the greater the absolute value of the slope, the steeper the line. That's my greater than symbol. Okay, the greater the absolute value of the slope, the steeper the line is going to be. All right, let's take a look at the next one. I'm going to graph this one in black. So the slope is 1, and the y-intercept is -3. Up 1, right 1. Or I can reverse it and go down 1 and left 1. And we'll say this has a slope of 3, or 3 over 1. And the y-intercept is fixed, it's -3 on both. But I'm going to go up 3, 1, 2, 3, right 1. I'm going to go down 3 and left 1. All right, and that's that line. So I'm going from the black line to the blue line. All right, so if you take the tip of your black line, you will have to rotate this thing up to get to the red line. Or if you take the tail end of the black line, this will be pushed this way. While this rotates up, this will be pushed down. Okay, but it's rotating up. So start off looking at the top part first, because it's going to tell you about the steepness of the line. Or you can look, you can see the red line is steeper than the black line, but you're rotating this thing up, guys. I can tell that the red line is steeper than the black line. Okay, so I'm going to say y equals to, oh, let's name this first. All right, so what's the same? Okay, same y-intercepts, or what we call initial value. What's different? Different slopes. So I'm going to say y equals to 3x minus 3 is steeper than y equals to 1x minus 3. Okay, and this is a rotation. It's a turn about the fixed point. And again, this is the fixed point, the point that it's turning about, your y-intercept. About the point 0, -3, guys. Hope that makes sense. Remember, the greater the absolute value of the slope, the steeper the line. Here the slope is 3. Well, the absolute value of 3 is 3. Here, still the absolute value of 1 is 1. This would be steeper. Let's take a look at this one. Here, M is 2, or 2 over 1. And B is 0. I'm going to go increase 2, go to the right one. Or I can decrease 2 and go to the left one. And just graph the line. All right, let's take a look at this one. The slope is -4 over 1. And the y-intercept is 0. So they do share that. They have the same y-intercept, sorry. And I'm going to go ahead and put different slopes. But let's go back to graphing B0 and go down 4 and right 1. Down 1, 2, 3, 4 and right 1. Or I can go up 1, 2, 3, 4 and left 1. And that's my line. So I have the blue line going to the red line. All right. So as we can tell, this thing's also been reflected across the y-axis, but we're not going to talk about that right now. All right. So I can tell that it's been rotated about the origin. Or what we call 0, 0. And I'm going to talk about the slopes. So here, this slope is 2, and the absolute value of 2 is 2. Right on the other one, sorry about that. This slope is -4. But remember I said it's the absolute value of it. The absolute value of -4 is 4. 4 is greater than 2. So the red line will have a steeper slope than the blue line. So I'm going to say y equals to -4x is steeper. Oh, let me go from the blue to the red. So I'm talking about what changes between the blue to the red. Between the blue line, which started off was my first, and that was my second one. I'm going to say the blue line, y equals to 2x minus 1, is less steep. So we want to always start off talking about our original line first, which was this one. Is less steep than y equals to negative 4x. All right, so let's take a look at summing this up. It says when the blank changes, but the blank remains the same, the function is blank about the point, okay? All right, so when what changes? What kept changing up here? Slopes was changing. Slopes was changing. Slopes was changing because they were different. The y-intercept was staying the same. Y-intercept was staying the same. Y-intercept was staying the same. But what was happening? It was rotated about the point 0, 0. Okay? 0 was my y-intercept. This was rotated about the point 0, negative 3. 0, negative 3 was my y-intercept. Negative 3, negative 3. All right, so we're going to put when the slope changes, but the y-intercept, also what we call the initial value, guys, remains the same. The function is rotated about the point. I'm going to put 0b because b stands for our y-intercept. And your y-intercept is always found on the y-axis, which means x is always 0. Okay? X is always 0 when you have a y-intercept. All right, let's take a look at some of these problems here. It says, without graphing, describe the transformation from the first equation to the second. Okay, this is my first to my second. Okay, I can see that the y-intercept stays the same. Thank you. All right, so the y-intercept is staying the same, and the slope changes. So the slope went from 1/2 to negative 3. All right, so the absolute value of 1/2 is 1/2, but the absolute value of negative 3 is 3. So I know this line got steeper because the absolute value of the slope, absolute value of the slope went up. But it was also rotated about the y-intercept, basically 0, 3, that fixed point. And I'm going to put y equals to 1/2 x plus 3 is less steep than y equals to negative 3x plus 3. I don't like all that being bunched up, so I'm going to rewrite it. Here the slope was 1/2, and the absolute value of 1/2 was 1/2. And then in the other one, the slope was negative 3, but the absolute value of negative 3 is 3. So I'm going to go ahead and put this here. It will look better. It's rotated about that fixed point, which is your y-intercept, guys. And we know the original line is less steep than the new created line. Then y equals to negative 3x plus 3. All right, that looks much better. All right, let's take a look at 2. Okay, on to the first equation has a slope of 1, and we know the absolute value of 1 is 1. The second equation has a slope of 2/3, and the absolute value of 2/3 is still just 2/3, guys. But we know 2/3 is less than 1, so we know that the original line became less steep once we rotated it. All right, so when the slope changes but the y-intercept stays the same, we know it's a rotation about the y-intercept, so it's rotated about the fixed point, 0, -2. Okay, rotated about that y-intercept. And then we know that f of x, and I like f of x and g of x much better than the red line and the blue line. F of x is less steep, excuse me, is more steep, sorry. Let's just go with steeper because it has a greater absolute value of the slope. So f of x is steeper than g of x. Okay. All right, you're going to pause the video and try 3 and 4 for me, okay? All right, so this is what you should have gotten on 3. The original slope of this one, I'm just going to rewrite this as f of x, guys. And I'm going to rewrite this one as g of x. So the original slope on f of x is -4, but the absolute value of -4 is 4. But it went from having a slope that had an absolute value of 4 to having a slope of -5, but the absolute value of that is 5. So I can tell that the original line got steeper. Okay. It went from having a steepness of an absolute value of 4 to a steepness of an absolute value of 5 for the slopes. All right, so the y-intercept stayed the same, so it's going to be rotated around that y-intercept or turned around that. And I'm going to say, I'm calling this f of x. F of x equals to -4x plus 3 is less steep than g of x equals to -5x minus 3. All right, last one. Let's take a look at 4. The original slope is 1, and the absolute value of 1 is just 1. This one, the original slope is -3/2, and the absolute value of -3/2, let me take this out. It's 3/2. Change that to a decimal, it'd be easier to compare. So I'm comparing 1 to 1.5. The original line got steeper, so the original line is gonna be less steep than the new one after the turn. All right, it's gonna be rotated or turned about the point 0, 0, or the origin, guys. And f of x equals to x is less steep because that's 1, and that's absolute value of 1. That's going to be absolute value of -3/2, which is 1.5. So I'm going to say f of x equals to x is less steep than g of x equals to -3/2 x. All right, let's take a look at this one. says graph the following functions on the same coordinate plane. Now these are different, guys. So far we know a translation that the slope stays the same, but the y-intercept changes. And on this translation, the lines are parallel too. Okay? And we know on a rotation that the slope changes, but the y-intercept stays the same. And that turn occurs around the fixed point of your y-intercept. But this is different. Okay, so I noticed on this one, I'm going to write this down, that the y-intercepts are the same. And we'll see if it always has to stay like that. But the one thing I noticed about the slopes aren't just different. The slopes are opposites of one another. So they have the same absolute value, but opposite signs. So what do I notice about the slopes? And let me go back and take that off because it says slope specifically. The slopes are opposites. Don't put different, they're opposites. One's positive, one's negative. Positive 1/3, negative 1/3. Now, the reason I'm really not concerned about the y-intercept, I know the y-intercept is the same, but if you go here, I only have one. Yeah, never mind, we'll talk about it. I only have one example of this, so we'll look at more. All right, so if the slopes are opposites, let's just go ahead and take a look and see what it says, what the graph looks like. So the slope is 1/3, the y-intercept is 1. We're going to begin at 1 on the y-axis and rise 1, run to the right 3. Excuse me. Or we're going to go down 1 and to the left 3. And I'm going to graph that original line. And that's the red one. All right, now if I change C's slope to its opposite, what happens? The y-intercept is still 1. But I've changed the slope to its opposite, so instead of going up 1 and right 3, I'm going to go down 1 and right 3 from that original point. Down 1, right 3. Or I can go up 1 and left 3. All right, I'm going to graph this. All right, so this is what's happening. One thing is a mirror reflection of the other. And I'm going to show you. If I were to take this was actually a sheet of paper, and I ask you to fold it along this line. If I ask you to fold it along this line right here, then that red line would end up on top of the blue line. So it would be a mirror image or a reflection. But it's folding it along the y-axis. We call that y-axis symmetry, okay? Or it's reflected across the y-axis. That y-axis is like your axis of symmetry. It's the line that makes one part of the graph the same as the other part of the graph or flip onto the other part, making a mirror image. So if you were to take these points, this point will actually flip over here and become that point. Or if you take this point and fold it along this green line, this point will flip over here and become that point. Or if you take this point and flip it across this green line, it'd flip over here. If I were to fold this graph along this line right here, okay, the y-axis. Same thing occurs on the bottom. If I were to take this point and flip it across this line, it would go there. Or this point and flip it across the line, it would go there. Or this point and flip it across that green line, it would go there. So if you fold the graph across that along the green line, which we're calling it the axis of symmetry, the blue line will be a reflection of the original red line. So we say that if you change the slopes to their opposites, all you do is reflect the line across the y-axis. That's all you do. You reflect the original line across the y-axis. In other words, Like I said, this point goes over here and becomes that point. It's reflected. It's a mirror image just across the y-axis. All right, so we're going to say it's a reflection. And some people call a reflection a flip. It's a reflection across the y-axis. And well, you could just say a flip across the y-axis. And if this doesn't make sense, guys, y'all just shoot me an email and we'll talk about when we need to do a meet so I can talk to you and you can ask me questions instead of just watching the video, okay? So it's a flip across the y-axis, guys. That's all it is. But that only occurs if our slopes are opposites, not just different, but opposites, okay? All right, let's take a look at this one. So graph the following function on the same coordinate plane. So I'm going to start off here with this one. I'm going to do it in black. The slope is 1. I'm going to put 1 over 1 so we can have a rise and a run. And the y-intercept is -4. Okay? So let's go ahead and graph that one. So we'll begin at -4. And we'll go up 1 and right 1 to graph the original line. Or you can reverse the slope and go down 1 and left 1. And we'll graph that line. And then I'll do this one in red. Okay, so I want you to notice something. The slope is not +1 over 1, but -1 over 1. So it says, what do you notice about the slopes? Well, the slopes are opposites. But the y-intercepts, let's take a look at the y-intercepts. Here, this y-intercept was -4. Here, this y-intercept is going to be +4. So not only are the slopes opposites, but the y-intercepts are also opposites. Okay, so both of them are opposites. All right, let's take a look at what happens. I'm going to begin at 4. And instead of going up 1, I'm going to go down 1 and right 1. Down 1, right 1. Or I can go up 1 and left 1. And I'm going to graph this line. Okay? So let's talk about what's happening when you change both the slope and the y-intercept to their opposites. So in the last example, it was flipped across the y-axis. These points were just flipped over here. Okay? They were just flipped across the y-axis. But let's look at what happens here between the black line and the red line. So I'm going to highlight one thing. Instead of highlighting the y-axis, I'm going to highlight the x-axis, guys. So let's look at the black line, okay? So if I were to fold this thing across that blue line, the blue highlighted line, let's see what would happen. Okay, just focus on the black line. If you fold it across this one right here, then this point turns into, excuse me, that point. But you got to fold it across this line right here. And this point will flip over and become that point. And this point will flip over the x-axis and become that point. Or if I go here to this part of this black line, this part of the black line, fold it across the x-axis, it will become that point. Or if I go here, fold it across the x-axis, it will become that point. Or here and fold it across the x-axis, go across the x, it will become that point. So if both the slope and the y-intercept change, it's still a flip or a reflection, but it's not across the y-axis. It's across the x-axis, guys. So this, if both of these changes, that's why I put 2, because both of them have to change to the opposites. It is a reflection, and another word for reflection that I like to stick to is just, it's a flip across the x-axis. But in order for that to occur, both slope and y-intercept must be opposites, guys. But now if you go back up here, the only thing that has to be opposite are the slopes. Okay? Only slope is opposite. And I got a little summary chart for you in your notes to help you out, but we'll get to that in a second. It's down here. So that's going to help you out, and I may let you keep that on the test to try to help you write some of these new transformations. All right, let me check that. All right, so when the blank is multiplied by -1 or changed to its opposite, and the blank remains the same, the function is reflected over the blank. Okay, so basically this is the only part. So only when one thing changes and the other one remains the same. So that one thing that changes was the slope. So when the slope changes to its opposite only, and that y-intercept or initial value remains the same, the function is reflected over the y-axis, the line that runs straight up and down. It's y-axis reflection, okay? But when the entire equation is multiplied by -1, and when I say the entire equation, basically, suppose you had, and you went from this to this, basically, if you multiply 3 by -1, and you multiply -5 by -1 to get to this and to get to that. Basically, you're changing both the slope and the y-intercept to their opposites. So that's when I say the entire thing. When I say the entire thing, I'm talking about slope and y-intercept, M and B. Okay? Both M and B. So when you change both of them, the function is reflected over the x-axis. It says in this case, both the slope and y-intercept are changed to the opposites. All right, so just for this part, all we wanted to do is determine whether it's reflected across the x-axis or y-axis to get from f of x to g of x. Okay, that's all I want to do. So let's look at f of x. Here the slope is -4, the y-intercept is 2. For g of x, the slope is +4 and the y-intercept is -2. Well, both of them have changed. So if both have changed to their opposites, it's simply x-axis reflection. That's all you do. So I want you to pause the video and try 2, 3, and 4 for me, okay? You can try 5 too. This stuff is easy. We'll do 5 and 6 on our own. Try 2, 3, and 4. All right, this is what you should have for number 2. Here the slope is 2/3 and the y-intercept is 3. Here the slope is -2/3, but the y-intercept stays the same. So only m, where the slope has changed to its opposite. So when only the slope changes to its opposite, we're looking at y-axis reflection, guys. All right, taking a look at number 3, the slope is 2, and went to negative 2. Slope is negative 1, went to positive 1. Both changed. So when both change, it goes to its x-axis reflection. All right, let me show you something on 4. On 4, the slope is negative 1/2. Here the slope is 1/2. But the y-intercept on both is the origin. So it's like plus 0 here and plus 0 there. So the y-intercept stays the same, but the slopes have changed to the opposites. So not both, but only one. So that puts us at y-axis reflection, okay? All right, take a look at 5. If we take a look at 5, it says write an equation, which we're going to call g of x, which will represent the reflection of f of x equals to x minus 5 across the y-axis, okay? We want to reflect it across the y-axis. So I only want the slope to change because it's y-axis reflection. So g of x would just be negative x minus 5. That's it. That's the new equation if you only want y-axis reflection, okay? All right, on 6, it says write an equation g of x, which will represent the reflection of f of x equals to 1/4 x plus 1 across the x-axis. So x-axis, I want both m, which is your slope, and b, m and b, which is your y-axis, y-intercept, to change to the opposite, okay? So I'm going to write g of x equals to negative 1/4 x minus 1. Change both of them to the opposite. All right, and just so you know, you try to pull it all together, I have a summary box, a translation. The y-intercept is going to change. I'm going to tell you slopes will be the same. Your lines are going to be parallel on these translations. And it's another word for it is slide. On a rotation, the slope is going to change. The y-intercept is the same. And it's going to rotate about the origin, a fixed point. You're going to rotate it about, I'm going to say the fixed point 0b. On x-axis reflection, both the slope and the y-intercept change to the opposites. On the y-axis reflection, only the slope changes to its opposite. All right, so what you're going to do is you're going to work on this packet 1 through 6. Let's see how many minutes this is taking. Hold on. No, I don't want you working on the packet. We'll do this tomorrow, okay? Just stop right there. What we'll do tomorrow is a part 3. We'll work on the practice. And we'll work on multiple transformations, okay, guys? So today you're just going to take notes. All right, thank you.